All right, welcome to this animation primer. Here in Unreal 4, we're going to be taking a look at some of the various ways that you can create or add animation within the engine. We're going to be looking at several different types of animation here, and I'm going to show you how all of those things differ and when you would want to use one type of animation versus another. The first type we're going to start off with is going to be one of the more simple types, which is just to use animation within a texture. Now, to do this, I'm going to import an image here, which is a flipbook texture. So I'm going to go into my images folder, and I'm going to go into import into the engine. And I'm going to go grab this flipbook texture that I've already prepared in advance. This flipbook texture is a series of images. I'm going to turn off the alpha channel so we can see it here better. A series of images that together create the frames of an animation. So when you see these played in sequence, one to the next, to the next, to the next, you end up with movement. Now, this isn't something that I created. I found an animated GIF online of a little fire effect that I thought was rather nice. And I plugged this into a website online that generated this image for me. Now, this website is essentially going to take an animated GIF and allow me to create a sprite sheet out of it, or as this is called in the Unreal Engine, a flipbook texture. And then so that's what I've gone and done is gone and pulled that in here. So we're going to use this in the creation of a texture here to see, the kind of animation we can get. Now, typically when you use something like this, a flipbook texture, it's going to be something that the subject matter is going to be something that is a little too difficult to create inside of the engine itself. So a complex fluid simulation, or in this case, a flickering flame that if you don't do it in this way, you're kind of bound by the particle system in the engine, and it can get really expensive to get something that looks really, really good looking. So by rendering this out somewhere else and saving each frame as a separate image, it is going to give us a much better looking end result. So I'm going to go and create a materials folder here in order to keep things nice and tidy in my scene. And inside the materials folder, I will go and create a new material. So this is going to be a master material, and I will call it flipbook, as that's what we are creating. Now, this is a really, really simple texture or material that we're going to be generating here. I'm going to go and turn off the grid so we can see this a little bit easier. I'm also displaying this on a plane so that we can actually see the texture here as it appears. I'm going to go and also make some changes to the base material before we import anything. So I'm going to make this not an opaque material, but a translucent material so that we can use our alpha channel to create transparency. And I'm also going to change the lighting from default lit to unlit. And this is going to remove most of the nodes on our output here so that we only have emissive color and opacity to really worry about. There are a couple of other things, world position, offset, and refraction that you can play with as well, but I'm not going to be using those at all. The first node we need is a flipbook node like this. Now, this is a function pre-built in Unreal that actually will take in an animated texture or a sequence of frames in a single texture and allow me to then go and play with how they're being displayed. So I'm going to take the result. Actually, let's just look at what this node does here. So you can see right out of the gate, if I go and preview it, there is a pre-built texture within this function that is just cycling between 4 images that are all contained within a single texture. So a red 1, a yellow 2, a green 3, and a blue 4. And we see them kind of cycling through. I'm going to go dock this here, and in my images, I'm going to grab the flicker texture that I've created. And I can do this one of 2 ways. I'm going to show you both ways here. I'm going to bring this in as a texture. And what we can do with the flipbook is we could use the resulting UVs into the UV of this texture object. So if I were to go and preview this, it's not going to look good just yet, but it is giving us the animation. The other method that we have for doing this would be to pull out from the texture 2D node and add a texture object. Now, the difference between these two things is that the texture object here does not have the ability to be played with. And really, that's the only thing I can see with the UVs don't exist as an input for this. There is, however, a UV input into the flipbook, which will result in exactly the same thing as having a texture sample here with the UVs going into it. And so either one of these methods will work really, really well. I'm going to stop previewing this one and delete it. We're going to keep going with this. So the next thing we need to do to set this up and make it work, I'm going to plug my results into the emissive so we can actually see what's going on. The first thing that we need to do are the two variables directly above the texture input, which are the number of rows and the number of columns. Now I've got this set up because there were 34 frames in this image. I've got it set up to be 2 rows of 17. And so we're going to create a couple of variables here that I'm going to go and plug their value in. So the number of rows is 2, and the number of columns is 17. So if I go and plug these in, we should instantly see the animation here playing the way that it was intended to be played. And so you can see that this gives us a really kind of nice looking animation here. So yeah, so that's why I like this one. Typically, if I was working on anything for production here, I mean, obviously you're not going to grab something from the internet and put it into your project. But what you would be doing is you would be going and generating this inside of another software package. So maybe you've got, you know, a fluid simulation inside of Max or Maya that you're going to render out into a looping animation like this, or maybe even just going into After Effects and creating something visually in After Effects that you could spit out. The key to making this work, however, is having that looping animation, each of its frames in a sequence that is going to be in a single texture. Now we have some other nodes here that we can play with as well. There's the animation phase, which is where in the animation we currently find ourselves. With nothing plugged into this, the animation is constantly cycling between 0 and 1. So it goes from 0 all the way up to 1 and then starts over again. This determines the percentage of where we are in the animation. So 0 is at the first frame. 1 finds ourselves at the very final frame, with everything in between being in between. So this is a normalized value. If we were to go plug another scalar parameter in here, or a constant value in here, you can see that we can actually freeze the animation. We're now on the first frame. And as I cycle through this thing, it'll actually go through and play the other frames. And so once I hit 1, we're back at the last frame. So the reason that that's interesting to note is that if we were to go create a time and we were to multiply time by some variable like so. So right now it's being multiplied by 1, so time is consistent. We can actually go and play around with the speed of this thing. So with time at 0, we get no animation, right? So anything times 0 is going to give us 0. So this is like freezing on the first frame of the animation. If I were to take time and multiply it by 0.25, we are going to get a quarter of the speed in the animation. So this is going to give us, and you can actually see each frame kind of popping now, which is why you'd want to kind of be careful with this type of slowdown. But it does give us the ability to speed it up too. So if I go 1.5, we're actually going to see it playing at twice the speed, or not quite twice the speed, 50% faster than it was actually rendered at. So this will give you a little bit of a smoother animation on this, but it does again play with just how quickly the animation is being displayed. The other thing that I can do with this here, because I do have an alpha channel in this image, if we go and look at this here, you can see that I've made an opacity channel here, is that I can actually just take the UVs out of this image and plug it in my opacity, and we'll actually get this rendering now without that background. So we can actually get something that looks a little bit more like a flame. Now, some of the downsides of doing animation in this way is that we are bound to a cycling animation, right? We don't get any variance in this in any way. It is just going to play that same animation over and over and over again without any variation. Now, there are some things that we could do that would kind of change that a little bit in order to kind of make it feel a little bit more dynamic, but it is always at the end going to be just a series of looping animations. And so some of the things that we could do would be to go and play with the UVs a little bit. So if you had a noise, I've got this little noise texture that I've rendered here, and if I were to go bring this in and plug this into the UVs, I'm actually going to do something with this a little bit. I'm going to create an if statement, and what I'm going to do is I'm going to plug the red channel into A, and we're going to set B here to be a value of 0.5. So any pixel that is greater than 0.5 will result in this bottom value, and any pixel that is less than 0.5 will result in this value. And all I want to do is I'm just going to use this to shift the UVs around a little bit. So if we were to go and take a couple of values here, I'm going to put this into A is less than, this one is in A is greater than, and all I'm going to do is just shift this a little bit. So we're going to go, let's see, 0.95. We've only reduced it by 0.05. And the idea is that if I were to go and pan this now, like this, and we're going to turn on the live nodes here so that we can see the panner effect happening. But I'm just going to go and add a speed to this. So let's add 0.5 into X, which should give us an animation going sideways here. That looks like it's a little too fast. Let's slow that down a little bit. And the idea here is that we're going to get this panning texture. And if I plug that into the UVs, let's actually make sure that we are appending this. Let's add it to a texture coordinate node. So we're just going to add that to the UVs and put this back in here. And what that should give us is it's going to give us this little bit of offset. And you can see, even with the 0.5, that it's not quite doing, the 0.05 is not quite doing what we want it to do. And so I'm going to put this at 0.99 and set this one to 0.01. And we're getting a little bit less of a distortion now. And then what I'm going to do is, instead of panning it sideways, let's pan it upwards so we can actually distort the flame a little bit. So let's add 0.25 to this so that this moves up. And that'll give us a little bit more of a variation in this. And I mean, we can always add a little bit of X in here too, so that it's going on a diagonal. But the idea is that this is going to manipulate the flame a little bit so that it's a little bit softer. And again, I could kind of blend this a little bit better. It's a little bit harsh right now, how hard that value is. But the idea is that this would give us something that is going to be a little bit more dynamic. And so, yeah, that's kind of how this works. There is a limit to what you can do with this. But in terms of being able to create animation and create things that move in your scene, this is definitely one of those ways that you can do that. Okay, the next type of animation that we're going to look at here is going to be using a mesh animation or a skeletal animation. Now, over inside of Maya, I've created this ceiling fan. And we're going to create an animation on this and export it. And we are going to make sure that this works in the engine as well. So the first thing I'm going to do is go and name the components of my mesh so that I can identify them in the engine. So this is blades and base. I'm going to hit Control-G to create a null, which I'll call fan. And then I'm going to parent the two objects to it. So I'm going to select my two meshes. I'm going to Control select the fan and hit P to parent these together. So now I have one object. Now what this is doing is it's creating a hierarchical relationship between these meshes, meaning these two geometry meshes are children of the group. And that creates what is going to act as a skeleton in the engine. Now you can also add joints inside of Maya if you wanted to rig it in that way. You could create a joint for the base and then a joint for the blades, and those joints could then be bound or have a skin bind applied to them to the geometry so that they then manipulate the geometry. That would be useful if we needed the geometry to deform. So if we wanted to have a bend occur midway through this pipe, now we would actually need to have some edges in here in order to facilitate that bending happening. But since this is a rigid structure and there isn't going to be any deformation in the geometry, grouping them together is going to create the same effect. So we're going to do this in two ways, and I'll show you both ways here. The first thing I'm going to do is I'm going to reduce the number of frames in my animation from 100 down to 30. So this is going to be a 1 second animation. So I'll hit save like so. And I'm going to start with the blades. I'm going to make sure that my time slider is over at the first frame, frame 0. And I'm going to hit S on the keyboard to set a keyframe. Now you can tell something's been keyframed if you have a nice dark red next to your input values here in your channels. And so if we go and look at this, it's dark red here indicating that there's a keyframe. And if I go to any other frame, you'll see that it turns kind of pink or a lighter shade of that red, indicating that these objects have been keyframed, but we're not currently on a keyframe. So I'm going to go over to the final keyframe, and the rotation axis here upon which I am rotating this is going to be my Z axis. And so I'm going to go into the Z axis here and give this a rotation of 360 degrees. That's not the right axis. Let's back to that frame. So when I created this, I didn't reset. Let's go and delete this keyframe temporarily here. I'm going to delete this. What I'm going to do here is I'm just going to reset my history, and I'm going to reset my history. Let's go back here, select all of this, and delete this key. So what I want to do is I want to make sure that I have nothing in my inputs here. So I'm going to freeze my transformations and delete my history like so. Okay, so then we'll start with the fan blade, hit S on the keyboard to set a key. We'll go to our final frame, and I'm going to rotate here. It's actually Y we need to rotate. So I'm going to put this into 360 degrees, like so. I'm going to middle mouse click inside of my viewport so that I'm no longer typing in here, and I'm going to hit S. And so now if we go to the first frame and we cycle this through, we will have an animation of that blade spinning. Now there actually is a problem with the spin, which you'll see if I hit play here. It seems to speed up and slow down. Now it's a little hard to see with how quickly it's playing this animation, but it is actually speeding up and slowing down. The reason for that is that when you create keyframes inside of Maya, it automatically applies an ease in and ease out to the animation, which is really good if you're doing a character or anything like that. But since this is something mechanical, I don't want the blade to speed up and slow down. So we're going to go remove that effect from this animation. To do that, I'm going to go to Windows, Animation Editors, and I'm going to go into the Graph Editor. Here we can see the animation in graph form. So here we have at our first frame 0 in the rotation, and as we get to the final frame, we get 360. This curve that you see is that easing in and easing out. So the animation starts really, really slow, then builds up speed and is at full speed once we hit the middle of the animation. But then as we start approaching the end of the animation, it starts tapering out and leveling out. So what I'm going to do is just select all of my keys. And up in the top, I'm going to use this little line tool here to make this a linear animation instead of one that contains curvature. So now it's at a constant speed moving all the way along. This is going to mean that when I hit play now, it actually just keeps spinning at the same rate. Now we have a hard time seeing this inside of Maya because of the rate at which this is playing and because of the nature of how it updates and renders. So we're going to go and export this now. I'm going to go to the fan. This contains both the base and the blades. You can see that everything's selected. And I'm going to say File, and I'm going to go to Export and Selection. I'm going to go and put this inside of the folder in which I'm saving my content. And then I'm going to go into Unreal, and we're going to go and import that here. So I'm going to right click and import, and we're going to go into that folder. So I'm going to go to Meshes, and I will go and grab the fan. On import, Unreal will detect that there's a hierarchical relationship between the components of these meshes, and it's going to try and import this as a skeletal mesh, which is exactly what we want. We want to make sure that it imports the geometry. Without this ticked, it's not going to bring our fan in, but only the animation. We want geometry and skinning weights, which there aren't any skinning weights. Everything is actually just animated itself. And then the skeleton we want to leave blank. So what this is looking for is what skeleton in the engine do we want to apply this animation to? And since there isn't a corresponding skeleton currently in the animation, leaving this blank is going to apply our skeleton as a new skeleton. So we're going to get 3 files that get imported here. The next thing that I want to do is I'm not going to bother creating a physics asset for this. And the reason for that is that I don't actually want physics to interact with this. Now, if your goal was to be throwing balloons into the ceiling fan and having the ceiling fan kick them around all over the place, then we would actually need a physics asset. However, since I'm not going to be doing that, I'm going to turn this off. Now, one of the other things that I typically do is that I don't create a physics asset on import. And the reason for that is that we don't really have a lot of options here in the creation of that physics asset. It's just create it true or false. But if you create it afterwards, we can then go in and manipulate the skeleton and the physics asset after and get the shapes and the volumes and the constraints set up the way that we want them to. So even if I did want to use this, I typically don't have it turned on. So I'm going to hit import now, and we will see our 3 files come in. Now you're usually going to get a warning here. I got one here that I couldn't find the bind pose. That's okay. I don't have a bind pose here. And I should have 3 files that have now come in. My ceiling fan, and this is the skeletal mesh, the geometry. I have an animation, which is the spinning of the blade, and I now have a skeleton. Now, if you open any of the 3 of these assets, we will have access to all 3 of them in one folder here. So if you look over on the top right, we can actually see those animations and skeletons and meshes here. So there is now the animation being played in Unreal, and I can see that fan blade chucking around, and it looks exactly the way that I intended it to look. And so, excellent. That's exactly what I wanted to do. To get this to play inside of our level, all I'm going to do is I'm going to drag the asset in, like so. Now I've got its pivot point here at the base of the fan, so I'm going to move it up so that we can actually see it. And if I were to hit play right now, let's actually bring this down a little bit so we can see it in our camera. If I were to actually hit play right now, you're going to notice that it's not animating. And that's because we just brought a skeletal mesh in. We haven't told it how we want it to behave in any way. So with the asset selected, I can go and find it here, selected in my outliner as well. And if I go and look at its details here, currently it's looking for an animation blueprint. Now, an animation blueprint is how you would control a skeletal animation if you needed it to change throughout gameplay. So, for instance, having a character enter a jump, we would want to use an animation blueprint to check and see if the character is in the air, and if they are in the air, play a specific animation accordingly. Since we're not going to be doing that with the ceiling fan, we don't want to use an animation blueprint. We're just going to tell it to play an animation. So with that drop down, I'm going to go and select the animation asset. And now it wants to know which animation do we want it to play. So if we had a multitude of animations here, we can actually choose different ones. I've only got the one animation, so I can either use the drop down and select it from my list, and it's only going to show me animations that fit this skeleton. There's only just the one. The other thing that we could do would be to select the animation and drag it over onto that slot. Below that, we have the ability to play the animation and loop the animation. We also have an initial position, so if you wanted to start the animation further into the animation than the first frame, you could go and set that here. If I were to go and hit play now, we would see that that ceiling fan is now moving and the animation is playing. Now, we could also go and tweak the play rate of the animation. So if I were to go and look at the animation itself, over on the left here, we have the rate scale, and we also will have the animation play rate. And this is going to give us the ability to actually play around with how quickly the animation is playing. And what that's going to give us the ability to do is it's going to give us the ability to speed this up and slow it down. So there's the rate scale. If I go and type 5 in here, it'll rotate much quicker. And if I go and type in 50 in here, it'll go even quicker. Now we're going to start getting, obviously, some pretty goofy looking animations here, as the rendering and the speed at which the blades are moving are not in sync anymore. Meaning every time the blade moves at 50 times its speed, the blades aren't visible in every frame of the render. And this is going to happen more and more and more as you speed up that animation. Now we can actually, if we were able to see our FPS here in the scene, we would actually be able to sync this up with the FPS, and we would get it so that you actually don't see any movement, even though it's rotating. And so you do want to be a little careful with how quickly you go and manipulate this. Now, if I was making something like a helicopter and I needed the blades to look like they're spinning the entire time, I would probably actually make an additional mesh that had a distortion in the blade, making it look like it's spinning. And you can see that we can actually, we can get varying effects here with that ceiling fan as we play around with its speed. Sometimes it looks good, sometimes it looks bad. And you can see sometimes it actually appears to start moving backwards, which is, again, something you get when the blades being rendered are rendering closer to the previous blade than the last. And so we can play around with all different kinds of speeds here. And that, because it is editing the animation, when I hit play, we are going to get that speed in the engine. Now, we can also make this look a lot better in engine than in the preview. And that's going to be based off of the motion blur that we get. So if I go and ramp this back up to, say, 25, and we were to look at this in the engine, you can see that we're actually going to get a much better render here than we were getting in the animation preview. And that's because there's a little bit of motion blur and other things going on. If I do put my cursor right here, though, we look at this ceiling, the blade of the ceiling fan here, you can see that it doesn't appear to be moving. It just appears to be kind of flickering. And so you can kind of get that issue. Now, there are only three blades on this ceiling fan. So when you look at this and you see all of these different ones being rendered here, that is the blades showing up in multiple places. So I'm going to turn that off. I'm going to go and set my animation back here to its default state. Maybe we'll do 1.5 and we'll speed it up a little bit. Let's see, 2, 3, 2.5. There, that's about as fast, I think, as I want it to go, so that I don't get too much artifacting here in the engine. So that is another way that we can do animation, is by bringing in a skeletal mesh, bringing in a mesh that has been animated in a package such as Maya or 3ds Max or what have you. The next kind of animation we're going to be doing is an animation that is done scripted-wise inside of the engine. So this is an animation where we are going to be using a script to make things move. So for this one, I'm going to make a conveyor belt. I'm going to move my ceiling fan out of the way. And what we have here is we have a barrel being spawned above and dropping down at the origin. And so I'm going to go into my level blueprint, and I'm going to go and back that thing up a little bit where its spawn point is. So here's its spawn point right now at 0, 0, 0. And so I'm going to take this X position here, and I'm going to set a, let's do -25. That's the rotation. Let's not put that there. Let's go -25 in X. And the idea is that I want the barrel to spawn a little bit further away than the origin. That's not quite far enough away. Let's make this 250. And so the idea is that I want the barrel, oh, we're going the wrong direction as well. I want the barrel to spawn further away from us, and then we'll create a conveyor belt that'll move it towards us. So if I go here and I hit play now, so the barrel is spawning back there, and we could probably move it even further back. Let's try 450. I want to get to the point where it's just barely hitting that platform. So there we are. We're right at the edge of the platform. And what I want to do is I want to create a conveyor belt that's going to move this towards us and leave it at the front of the screen here. You can see our ceiling fan is creating a lovely dynamic shadow on the ground. So let's go and do that. Let's do this by creating a blueprint. And I'm going to name this blueprint. This is going to be an actor blueprint because it's an object we want to place in our world. And I'm going to name this BP underscore, so blueprint underscore, and conveyor. Okay, now what we're going to do with this conveyor belt is we're gonna set up a couple of things in order to get this to move the way that we want it to. So if you remember, I moved the barrel back to 450, and I should actually do this at both points where we are spawning the barrel, because the new one will not show up in the right place, like so. We don't need our level blueprint anymore, so it's going to spawn the barrel over at the back of the world, and then we're going to have it move towards us. So I'm going to add a couple of things to our scene here, to our blueprint. Under components, I'm going to do a search for box, and we're going to add a collision box. Now, the collision box is actually where the conveyor belt is going to exist. And so I'm going to want to go and play around with its scale a little bit to get it to match the shape and dimensions of the conveyor belt. So we're going to go and into our scale. And if you remember, we were moving this along X. So it's X that I'm going to want to truncate here or exaggerate. I'm going to set the height to be +1. And I'm going to set the X of this thing to be a lot bigger. Now this is a let's do this at 12. So something like that is going to work. So that is the length of our conveyor belt now. Now what this box is, this is a collision box. And what it's going to do is it's going to be checking inside of the world to see if anything has been placed here. So I'm going to move it up in the world, and we're going to go add a box. Let's add a static mesh or a cube here. I want something to act as a stand-in for our geometry as well. So I'm going to go and set this to be a similar dimension here. Let's do that. Where did you go? Cube. Let's go and put you back. Let's set this to 12, 5, 3. Well, this is parented incorrectly. Let's do that. So the idea here, let's go and reset this back to 0, is that this is what our conveyor belt looks like. And so I'm going to just get it close enough to the size here. I think we need 0.7 here. And I'm going to scale it out like so. And that's going to be the stand-in for the actual conveyor belt. So this is the piece of geometry that we're going to see here that people are going to presume is the conveyor belt itself. Okay, so I'm going to go and put this down here like this. I wanted to line up here as best I can with the bottom of that collision. It's pretty close. Let's go over here. There, something like that. So we'll go back to our perspective view now. So this is going to be the conveyor belt itself. So we would put a panning texture on here that makes it look like this thing is moving, or we can actually make an animated piece of geo that actually does move and go in this direction. And so what we want to do is we now want to set this up so that anything that enters this box starts moving along the collision or moving along the conveyor belt. So this box is kind of our, if you touch this, then move kind of script. So inside of the event graph, we're going to do a couple of things. The first thing that I want to do is I want to check and see if anything is in the collision volume. And so I'm going to select our collision volume. And inside of our events for that object, we're going to say begin overlap. And we're also going to add an end overlap. Now, the reason I'm adding both of these is that I'm going to be using tick. And tick is pretty expensive. It's not something you want to use willy-nilly in your projects because it does get fired off every frame. And that can get really, really expensive. And so what I'm going to do is I'm going to use these two objects to determine whether or not we should be doing this. So the last thing that I want to be doing is moving a bunch of stuff on the conveyor belt if nothing's actually there. And so that's what this is going to do. It's just going to check and see if anything's on the conveyor belt. And if something is on the conveyor belt, then we'll allow this to work. And if nothing's on the conveyor belt, then we'll stop it from working. So what I'm going to do is I'm going to create a new variable, which is going to be a Boolean. And I'm going to say, can move ? And we're going to go set this. So if something is on the conveyor belt on component begin overlap, then we're going to set this to be true. And by default here, we're going to make sure that this is set to false. Then if nothing is on the conveyor belt, we're going to let this become false. So now what this is going to do is whenever anything touches the conveyor belt, this gets set to true. And when it leaves the conveyor belt, it becomes false. Now I can go to my tick and add a branch. So I'm going to hold B and click, and we'll output from the tick into the branch. And what we want to do for our check with the branch is just see if we're allowed to do anything. So now tick will only fire off if one of these things is going. Now it is doing this check every frame, which is a little bit expensive. But since it's just checking to see what a variable is set at, we're not doing too much here. So this is going to limit just how expensive this is. Meaning, when nothing's in the box, that's it. This is not, false is not going to fire off. It's not going to do anything. So what we want to do now is we want to actually run the bit that is going to move the conveyor belt. So what we need to do is we're going to find out what is inside. So we've got this little collision volume here. Let's find out what's in the collision volume. What is the thing or the things that we need to move? So I'm going to right click and I'm going to get overlapping actors. Okay. And what this is going to do is it's going to take a look at everything that is overlapping. And because this is set to self, it's going to be checking everything that's overlapping that box. Next, I'm going to pull out from here and we're going to do a for each loop. So for everything that is overlapping our object, let's do the same sequence of events. This has to go into true because again, we're checking to see if anything can be moved. So if anything can be moved, true, let's find out what needs to be moved and we'll do this for everything that needs to be moved. What we're going to do to move things is we're going to add an offset to them. We're going to essentially just start shifting them along. So for everything in that array, we're going to add actor offset. And we're going to do a world offset here. Okay, and we're going to plug this in. This is going to give us the ability to then move things in any direction that we're currently looking to move them. Now, how do we move them? How do we get the formula that we put in for moving? Well, coming out of tick, we have something called delta seconds. If we pull out from here, we're going to go and multiply this. So we're going to do a float times float. And I'm going to create a new variable out of this one. So let's promote this to a variable. And we're going to call this variable speed. Now what this is going to do is this is going to give us the output of delta seconds times a variable that we want. So you can think of this of how many units per second we want this thing to move. That gives us our speed. The next thing we need to do is figure out which direction we want things to move. So again, this is a vector. This is an X, Y, and Z. So we need an input for X, an input for Y, and an input for Z. So we're going to do this dynamically so that if we move our object, it moves it in the right direction. So let's get actor rotation. And this is going to check and see from self, from this blueprint, which direction it's pointing. It's going to get its orientation in the world. From there, we are going to get the forward vector. This is going to take the direction that it's oriented and find out which direction front is facing. Then we just need to multiply that against our float that we've created for speed. So we're going to do vector times float like this. And that's going to give us now the input that we need for our delta location. This is then going to move things in the direction that this blueprint is moving when something interacts with it. I'm going to compile this and let's go and put it into our world. So here's our blueprint conveyor. I'm going to make sure that I put this at the origin here so that it ends up in the right place. And I'm actually going to slide it back a little bit and up a little bit so that our barrel lands upon it. Now, we do have to do one more thing here, and that is that that's supposed to happen. That is that we need to make sure that the box, anything that encounters the box is going to fire off an overlap event. So we have this barrel that we're spawning here, and we want to make sure that this is going to have in its collision that it is going to have a overlap event, triggers overlap event. So if we go in here, we do a lookup for this. Looks like it's not in here, so we should actually be okay. Let's give it a try and see if it works. So no, so it's not actually firing off. So it is moving. We also have our speed set to 0. So let's go and give it some, let's give it some speed. Let's say 200 frames or 200 units per frame. So again, the barrel falls. You can see that it is landing on the box, but it's not firing off that collision. So let's add a print here and let's double check and see that it is actually firing off. So what I'm going to do is I'm going to print the, let's print the overlap here, can move. That didn't work. Let's put this here. And let's just print the variable to see. How does that keep happening? Let's just go print the variable to see if it actually is firing off. And you can see that it is not actually firing off. So what that means is we have to go make changes in the level blueprint to the way that this works. So open level blueprint. And what we want to, the property that we're looking to manipulate is the overlap. So we need to make sure that the object being spawned, the barrel, generates an overlap. So generate overlap event is what we're looking for. So what I'm going to do is I'm going to, in the object that is being spawned here, we're setting physics, we're setting mobility. We're also going to overlap. We are going to set, let's do this, generates overlap events. So we need to make sure that this object, and I'm going to just add this to the chain, is also generating an overlap event. Okay, so I've gone and put that in after the spawn here, and I'm going to put it in after my other spawn here as well, so that in the list of things that we're doing to this object that is spawning, we are continuing to do that. So if I hit play now, we should actually get that true, and it is firing off. You can see that false fired off as well. The other thing that's an issue is it moved backwards, right? So it spawned on our conveyor belt and went away from us, which is a little bit of a problem. So one of the things that we could do inside of our blueprint to help us out is I'm going to go and add an arrow component in here, like so. And the arrow component is going to show us the directionality of travel. So I'll put one here, and I'm going to duplicate it, and we'll move this one to the back. Like so. So if we go look in the world now, we can actually see the direction of the conveyor belt travel. So that's no good. Let's go and rotate this thing 180. And then I'll hit play, and the barrel will spawn on the conveyor belt. It'll come towards us. It'll fall off the conveyor belt where it stops triggering. And now when I hit my explodey little button here, the barrel will disappear from the beginning. And when I spawn another one, it'll spawn on the conveyor belt and come towards us again. Now, I'm going to eject from here, and I'm going to show you one of the issues that we have, which is the barrel, while it is coming off of that conveyor belt, it still has its leg here a little bit on the lip. Now, the reason that that's happening is that in our conveyor belt, if we go look at the edge here, the barrel is allowed to leave the conveyor, the actual volume that is moving it, before it actually finishes leaving the platform. So we may want to move this platform a little bit in order to give it the right scale. Looks like maybe 6'8". Like so, and that should actually let the barrel fall off the edge here. Now I do have to be careful that it doesn't roll away on us, but now it is falling flat at the end. Now the really nice thing about this is that this is a blueprint, and the reason that that's important. So I'm just going to move this back, and I'm going to hold Alt and move it again. What that means is that we actually have a manipulatable system here now. So if I go and put this one here and move it this way, and I just want to make sure that we have these right up against each other here. What that means is that when the barrel spawns, it'll leave one and go onto the other. And so we can actually have this kind of moving about the environment in that way. Now it did kind of take a funny bounce where it went in one direction, where it was getting the input from both of them, but that's okay. That's kind of how that would happen. And yeah, we can actually have this kind of going around the environment in that way. I can also scale these things and they'll still work, like so that the barrel will go from one to the other and then off at the end. And so we can actually set up all kinds of really neat dynamic things in the level in this way. And so that gives us another type of animation here. We're now scripting things to move in a particular way where we can actually just tell them, hey, go from here to here, and it's now doing that. One of the other types of animations that we can do as well is a physics-based animation, and that's something that's happening on the barrel. You know, the barrel is spawning above the world, and physics is dragging it down, and that's a pretty easy thing to do as well. It's something we're already doing, where once this object spawns, we're just telling it to set simulate physics to true. The barrel will then fall on its own accord, and then just do whatever the world tells it to do. Now I'm going to go in here and kill the print like this so that we don't print that any longer. And yeah, we now have a conveyor belt allowing us to move things about the world. And so if I wanted to set this up so that we don't see the spawn happen on screen, you know, I'm going to go and create another version of this thing here that will go and dock up here. I don't know my snaps on at the moment because I turned them off when I was editing the blueprint. So I'm going to want to try and get this as accurate as I can here. So something like that. And what I would do now is I would actually want to go and find out where the end of this object is over here. I'm just going to grab an empty actor to go find the position where I would like to spawn my barrel. Now, which, let's see, 705 is going to work, and 550. Yeah, 550 will work. So I'm going to spawn it at, oh, that's actually not going to work. It's going to go off the edge. These have to line up this way. If I had it actually, I was going to spawn it and have it just fall off the edge of the world here. And so we're going to go and do this like that. So again, I'll use my little empty actor here to figure out where I'm going to spawn the barrel. So 475 and 705. And so if I go into my level blueprint, we're going to change the position to 475. And actually that's 705. Is that right? Yeah, no, that's right. 705. So we're just going to go put it there. Let's try that again. 475 and 705. Like so. So if I go and save this now, what we're going to see happen is that barrel spawns off screen, lands on the conveyor belt, and then is going to come around to us and end up in the right position where I can then now explode it. And so the explosion button will now work. We'll get a countdown timer. The barrel's gone. And when I hit reset, again, that barrel will spawn off screen but land on the conveyor belt, which will then move it into place. Like so. And so that is a look at animation here in Unreal, the different types of things that we can get set up. Obviously, this is a primer and not the only means by which animation can be done, but it definitely gives you something a little bit more dynamic to play with, and makes the world feel a little bit more alive. And so I hope that has been helpful. And until next time, thanks for watching. And we'll talk again soon.